EKG of the week. Let's look at another real life EKG and pick out the finer and maybe not so finer points of it. Maybe some stuff's a little more involved on this one. Let's take a peek. So we have this EKG here. Let's take a look at it, pause the video, and come back, restart it when you have an interpretation about what you think is going on with this EKG. Let's take a look. Let's go through the algorithm so we don't miss anything. So we start with rate. I like to count just the number of QRS complexes across the bottom because I know it's a 10-second strip as always. So when I count, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and maybe just a skosh more. But let's call this a rate of 12, which 12 times 6, it gives you a rate of 72. So that's a normal rate, and certainly it looks like a normal rate. Rhythm-wise, a little bit harder to determine on this one. We're looking for P waves mostly, and is there a P wave before each QRS, and does a QRS follow each P wave? And the P wave is a little bit hard to find, to be perfectly honest here. When we look through it, I'm going to call it a sinus rhythm because I think I see P waves, but they're sort of hard to see. Like that looks like one there. That PR interval, looks right about there. Is the next one sort of the same? Yeah, it is. Now it's awfully close to the T wave there. It's kind of hard to sort out whether that's like a U wave or is that part of the T wave. But I think if you track that out, that kind of tracks with these little bumps as well, which maybe it's part of the T wave, but it's a little funky if it is. But more importantly, the PR interval, which we'll get to in just a second, that the space from the start of that P wave to the start of that R wave, or in this case the Q wave, that is consistent if we lose that little bump all the way through. So that doesn't change, even though the heart rate may vary ever so slightly. That PR interval is the same, so I'm going to say that that's a P wave, and I'm going to say that this is sinus rhythm because it looks like there's one of those little things before each of the QRS complexes, and it looks like a QRS complex follows each one. So we'll call it sinus rhythm, and again at a rate of 72. Rate rhythm axis. Axis, good old axis. Coming around to it, to be perfectly honest, this is one case where it might actually make a difference to you. Again, if you had to skip something, maybe, but in this case, all of a sudden, it might be really important for a reason that we've actually already talked about on another video. But let's look at the presumed axis. So we're going to look at lead 1, lead AVF, and lead 2 to determine it and see if the QRS complex is mostly above the line, mostly below the line, or is it if it kind of splits the difference. And we'll say when we look at lead 1 here, I'm going to say it looks like there's maybe a little bit more space between the downside of the QRS complex than the upside. It's a little bit more negative, I'll say. It looks a little bit more on the negative side, but pretty close to splitting the difference. That's lead 1, so kind of splits it, maybe a little more negative. Lead AVF is mostly negative, it looks like. Lead 2 is mostly negative. So when we fire that on over to our chart and we look at it, we said lead 1 is maybe a little bit on the negative side, maybe not convincingly so. It's mostly isoelectric, but maybe a little bit negative, which is going to be over here someplace. But again, probably either close to straight up and down to lead 1. We said lead AVF was also negative. The negative side of AVF is over here. Here's the positive side. Here's the negative. So it has to follow somewhere up in here. And then negative in 2 as well, which is over this direction. So the only place that makes all three of those things happen in this chart is this area up here. And again, it's probably, since it's isoelectric or pretty close to perpendicular to lead 1, it's probably close to this line here. This is, like 270 over here, probably somewhere right in here, but ends up in that weird extreme axis deviation, this no man's land, the place where hearts just don't usually have electrical activity, because if you think about what that's saying, it's saying that most of the electrical activity in the heart seems to be going from down here at the apex of the heart and up the opposite direction towards the right shoulder. And that's just not the way that current usually flows through a heart. So when we see that, again, even if you don't know anything else about it, just kind of know that this part up here, just based on whether or not these leads are positive or negative, mostly, the QRS is positive or negative mostly, just knowing that says, this is in this weird section, and that really shouldn't happen. Whenever I see that, my first thought is, did we mess up this EKG in the acquisition of it? Talk about it in a minute, but that gives us an axis somewhere in this like way extreme axis deviation that shouldn't really happen. So we've got a rate, about 72. Rhythm looks to be sinus. Our axis ends up in that no man's land, extreme axis deviation. Something seems funny. Now, it's not that it couldn't happen, but it's just kind of atypical for it to happen or pretty atypical for it to happen in a living human being. Rate, rhythm, axis. How about the intervals? Let's run through those real quick. So when we look at, let's start with our PR interval, because we talked about that a little bit already. Let's find a good P wave that looks easy to see. It looks like that little guy there. So the start of the P wave to the start of the QRS complex ought to be less than one big box. And it does not look like it's less than one big box. In fact, it looks like it's a big box and two little boxes. So that is a long PR interval. Let's look at the QRS complexes. And again, we can kind of pick wherever, but let's pick this one. Should be less from the start to the finish of the QRS complex. And it's fairly clear here. It ought to be less than three little boxes. So that looks like one little box, two little boxes, three little boxes, four little boxes. So this is a wide complex QRS. It's greater than three. And then again, the other interval that I kind of look at sometimes or care about mostly is a gross estimation of the QT interval, which again, if you take kind of the peak of the QRS to the peak of the QRS complex and look and see if the T wave finishes before that is like halfway through, essentially halfway between the space between the interval of the QRS complexes. Boy, that's not very clear to understand, but if it looks like the T wave is not finished by the time you get halfway to the next QRS complex, that may be a long QT. In this case, it looks like the T wave finishes before that space in between the QRS complexes in fact is halfway, which would be right about here. It looks like the T wave is already finished, so this is, let's call it a grossly normal appearing QT interval. Of course, there's a lot of calculation that could go in that, and the computer will do that for you. But in this case, it doesn't look like it's particularly long. You can see that kind of down here too. And this is maybe a little bit better. The R to R interval, the peak from here and the peak to here. Is the T wave finished halfway before that is completed? Yes. The halfway point somewhere around where the center of that circle is. So we said we've got a probably first degree AV block or a long PR interval, if nothing else, that looks consistent. So that's probably a first degree block. We've got a wide complex QRS and a normal QT interval, at least we think. And I kind of gave you the next part, rate, rhythm, axis, intervals, blocks. Let's look at the different blocks. Again, AV. Start with AV blocks. We've got a long PR interval each time, but it looks like it is at least consistent. There again is that long PR interval. It doesn't look like that PR interval changes though. So this looks like just a stretched out PR interval. There's always a QRS complex that follows that. You don't drop any beats, and it looks like it probably is associated with the QRS complex. So this is probably a first degree AV block from what we kind of see here, just a long stretched out PR interval. I'm trying to find you another place where you can really see that real clearly, and unfortunately, there's just not a lot of them. These are kind of funky hidden T waves or P waves. So we think this is a first degree AV block. How about left bundle branch or right bundle branch block in terms of morphology? This EKG has the morphology of a right bundle branch block, which again is either a R, R, S wave, and then another R wave where it comes up, makes the M or the bunny ears that we're kind of seeing here. In this case, you don't see a lot of that first R, but you do see the second one. And the second one is really what makes it, that positive deflection after that S wave. That is what makes it the right bundle branch block. So it's a right bundle branch block morphology, even if it looks a little bit funky and doesn't look like the typical one that you see. At least that's what we see out here. Now, when we look in like the limb leads, though, that looks a little funny. That kind of looks like not something that we see real often. Just FYI, when we're looking for blocks, like bundle branch blocks, usually the QRS complex is positive here, and it goes kind of up and then down and has a little bit of a slur at the end of it. So something's a little bit off just when we look at it, but we'll get to that in just a second. So we think it's a right bundle branch block. We think there's a first degree AV block as well. All right, so we have rate, rhythm, axis, intervals, and blocks. Let's talk about ischemia and infarcts. Again, ischemia, we're going to look for T-wave inversion and ST depression. And infarct, we're going to look for what we think of like STEMI, ST elevation, greater than a box, which is significant, or maybe a little bit more in V2 and V3. And also Q waves. So let's look for ischemia first. We can just kind of scan through here. Start with the kind of high lateral leads. No obvious ST depression there. There is a flip T wave. Don't know if that's old or new. It'd be abnormal if it's new. Same thing here. Flip T wave. No obvious ST depression that we appreciate. When we look through the inferior leads, again, no depression, normal T wave, no depression, and no depression, no flip T wave there. At least doesn't look like it. No significant. We're scanning through the precordial leads. Flip T wave in V1, meh. Maybe a little bit in V2 and V3. Hard to tell if, again, that's old or new, and it's not reproduced on every beat, so the significance not entirely clear, not clearly like a huge ischemia, and no ST depression with it. And then same thing up here. Normal T wave or normal upright T wave, normal upright T wave, normal upright T wave, no significant ST changes that we see with it. So that's the ischemia. Let's again go back one more time, and you can do this faster when you're doing it on your own, but I go through and just look for gross ST elevation. You might think that there's a little bit of ST elevation there. When you actually put a line across it, it doesn't really look like it's very much. The top of that one line is maybe just a little bit elevated, but there's a little bit of wander in the baseline too. So no significant ST elevation in 1 or AVL. Again, you might kind of think about it depending on what segment you look at in lead 2 here, but it's certainly not reproduced as significant ST elevation or an AVF. And then scanning through the precordial leads, same thing, no significant ST elevation appreciated as I kind of roll down here through these real quick. So we do have some T-wave inversion that might indicate ischemia if it's new. We don't see any obvious signs of infarct, no ST elevation. However, I did skip a little something and said that ischemia is T-wave inversions and ST depression. Infarcts are usually, ST elevation we think of. What about an old infarct or one that's kind of gone to completion that would be manifested by an abnormal Q wave? And we do see Q waves when we scan through here in lead 1, in lead AVL, and also in lead 2. Get a little bit, there's an R wave there, not technically Q waves. But we got some Q waves out there. And something just doesn't seem right to where those Q waves are at, because that means they've had an infarction someplace, but it's kind of hit the lateral leads and lead 2, which is kind of the inferior side, and they're kind of close to opposite sides of the heart, essentially. Something just doesn't sit right with that. Plus, lead 1 looks funny and lead 2 just looks funny. So I'm going to say that the pattern overall is something just doesn't look right about this EKG. Now, there's lots of stuff going on with it. It's got a first degree block. It's got a right bundle. Those we kind of know about. But when I compared it to an old EKG, it looks a lot different than the old EKG as well. And when that happens, and this is a person that's not complaining of any specific like chest pain or anything like that, when that happens, I got to think to myself, like, is this EKG really something that I can believe in, or is something going on? And in fact, when you look at the top of the EKG, what it reads is this computer interpretation. Lots of funky stuff here, but unusual P axis. Whenever the computer says unusual, then I start to wonder if this wasn't an acquisition problem rather than a heart problem itself. If you see something that looks funky on an EKG, my first step would be to repeat it and replace, don't just like hit the reacquire button, because that's probably not going to do it. Consider even taking the stickers off, but at least take all the leads off and put them back on, and you may find the key to why this looks so funky. So here is the repeated EKG, and it looks markedly different than the last one, at least in terms of those things we just looked at. The funkiness in lead like 1, 2, AVL, those Q waves have all kind of gone away. And when we compare the two of them, the old one, the first obtained one rather, is the one on the right. The new one is the one on the left. We can kind of look at what looks different between those. So you notice on here that if I look at lead 1 on my new one, get a good picture of that. It's got this little point at the top, but it's mostly upright, and then this big slurred thing that's mostly negative. On the old one, it was a point going down, and it's this big slurred thing that's mostly positive. It's like you flipped it upside down. So lead 1 looks flipped. When we look at lead 2, I noticed that lead 2 on the old one, it's got a little hump, little positive hump initially, and then this kind of notched negative QRS complex down there. That looks a lot like, that's again lead 2 on the new one. That looks like the old lead 3. So that guy looks a lot like that guy. Curious. Wonder if it has something to do with what's going on with the EKG. And then when I look at lead 3, you may see where this is going. I see a little positive hump, negative deflection, another little positive hump. When I compare that to my old lead 2, I see little positive hump, negative deflection, little positive hump. New lead 3 looks like what old lead 2 looked like. Something you might be seeing a pattern already. Even when we look at the augmented limb leads, AVR, AVL, AVF, we can go through those relatively quickly here. When we see AVR, you notice that AVR looks a lot like old AVL. So there's old AVL, or this is new AVL, but new AVL looks a lot like new or old AVR. Old AVR or old AVL looks a lot like, again, negative, positive, little humpy deflection there. Looks a lot like AVR previously. And then AVF, negative, or let's see, little hump, negative complex, little hump. Still kind of looks like little hump, negative complex, little hump, going side to side. So AVL looks like AVL and AVR seem to have switched, and AVF looks kind of the same. This leads to our grand conclusion that what has happened here is that the patient's heart did not undergo some sudden shift in axis and something crazy happened with the electrical system, or they had some sort of huge heart infarct or something like that, especially in this asymptomatic patient. This was a limb lead reversal. And of course, we say it's a suspected because I didn't actually see the guy put the leads on the initial EKG, but I did see him put it on the second one, and I know on the second one that they're placed in the right way. All right, this has turned into kind of a long one, so I'm going to break this into 2 videos, and so check that out to get a little bit more into the nitty-gritty. If you just wanted the interpretation on it and to run through another one, then that was what you've seen up to this point. And otherwise, stay safe out there, and we'll catch you later.